Greetings. Spinning ball illusion. Okay, there'll be no code for you. This is just something I worked on for a long time just to play with. And, well, I don't have much hair to lose, but I know I lost a hair doing this. This was quite a challenge for me. Let's go on and look at what I did. I got this PDF right up here, and I'll put this out with a file and the test files of this here that you can actually play with. Okay, this might take a little while here. So a few months ago, I seen a computer illusion on Instagram, I believe it was. And I said, well, that's kind of cool. I wonder if I could duplicate that in a COCO 3. Well, in this line here kind of says it all. Well, on a 16-bit 2XX megahertz 320 pixel COCO 3 will not match a 64-bit gazillion colors 4 gigahertz. You got 2 megahertz versus 4 gigahertz. Not even close. Okay, here's the example I seen. This red circle here with these 8 white dots, and they just kind of go around in a circle around inside this ball here. Okay, I worked on it and I threw so many pieces of code away and tried and finally started getting somewhere. I got the circle, but it was fairly simple, and I got all the diagonal lines for the 8 balls. Okay, or the 8, cut it up in 8 pieces of pie there, or 16 really. And here's what I ended up with my version of what I see on the screen. These going around. Okay, I tried calculating addresses for all 8 balls. I started with just one ball, I get one ball to work. But it was very slow with all the calculations needed. You got lots of calculations as things go or moved around the screen. I had all kinds of tables with starting points, deltas, offset, and all sorts of stuff. Here's just some examples of the various versions I had. Different tables, these deltas, and play things on the screen, and that. And here's some other parts of the tables for the lines. Okay, where it was on there, the width and the radiuses and offsets, and some other tables. This delta 2 at 22.5 degrees, where would it end up on the screen? Just trying to do all these calculations on that 16-bit machine, it just really bogged it down. Here's my final solution. It's a basic program to calculate the sine and cosine and put out a file for each ball. Okay, and I did. Every one of these have a different degree around that spoke in there. Okay, 0 degrees, 22.5, 45, etc., 90, and so on and so forth, which will give me an offset of nothing will give me an x coordinate of 206 or hex CE, and a y coordinate 115 or hex 3, and a calculated screen address where it was at this 22.5 degree radius. Where would it end up on the screen? And here was these. That's what I was looking for, was these calculated screen addresses for each ball at various times. Okay, again, it worked out pretty good. One problem is when I originally drew the lines on the screen, some of my calculations I was off by a few degrees during my calculations, and I kept using them as my basis. Well, when I got down to the balls weren't on the lines, so I had to adjust to get it to work. Okay, and as you'll see in the demonstration, not all the balls are 100% where they should be. But again, I got tired of working on it after so long, and I'm tired of this. I'm done. Added a debug option in there. You'll see that in the demo. And one of the note here is getting the balls to move and not cross the center point the exact same time is quite a challenge. Okay, here's my final screen. Okay, this is part of the snapshot of it. Here's a circle with the balls in it. And this is when it's in debug mode. It will print out all these addresses where it's actually calculated with what I put in, plus the offsets in there. It's somewhat complicated anyway. That's what and there's also type in H for help, and here's a help text of all the things you can do. Okay, is what it does. Different colored lines and turn them off in individual balls at a time. So let's take a look at this thing. Okay, there's three pieces of program. There's the basic program, which is this one here, which is called Wheel QQ. Why QQ? I don't know. I just needed something because that has where my tables were in this bin file here. I just used a number, and that's why I come up. Okay, and all it does is it brings in block 35, like we've done another test. It loads up all these tables here with an offset to 5600. When it's actually used, it's up at dog 600. It brings in our letters file, which I think was in lesson 18 where we looked at a lot of that. It brings it in, we'll execute it at dog 00, and then it will tell you to load this in here. So let's go ahead and run this here. It says wheel 05. Okay, if I had the correct number, it'd probably be wheel 500, but all the times I did it. Okay, now let's just execute it and we'll take a look at what I come up with. Okay, I got it where it stops all the time. Instead of continuously going around the circle, I got it where it stops. Okay, so that's my version. And you'll see it, if you'll notice a couple of the balls are out of places, it goes around. But then again, I got tired of recalculating each one of these things here. So, and that's what it does. Okay, kind of neat. Okay, well, now back at the very first screen, it said spinning wheel illusion. Okay, well this really is an illusion. It's what you're looking at. It's not what you think it is. Okay, let me put the lines on there. Okay, that was my first time I put the lines on there. I had different colors for different balls and stuff like that. I liked it better with the black lines. But anyway, it spins around. So what I'm going to do is F will turn off all the balls. Okay, and I'm just going to do ball number 1. Okay, it's all ball number 1 does. Goes back and forth. Now I'm going to turn on ball number 5. Okay, that's all he does. Just goes up and down. One goes right and left, one goes up and down. Now I'll turn on ball number 3. I'm going to hit the slow down button here so you can watch them. All they do is follow a line across the screen. They don't go anyplace else but on one, they follow a line. Now turn on ball 7. Okay, so you got half the balls on. As you can see, they're not going around in a circle, they're just going up and down and across. Okay. Now I'm going to hit the O button and turn them all on and do it again. Okay, so it looks like they're going around, but they're not. They're just all following the lines around. Or all you do is follow a line. I'm going to turn them off again, and let's try ball 1. Oops. All right, that was ball 2. Now I got 1 and 2 on. Add 3. Add 4. Oops. Keep pressing the wrong keys. Okay, we'll just use the first 4. And you can see how it looks like they're kind of going in a circle, but all they are is following the path back and forth, back and forth, back and forth. And the key was not to hit that center mark at the same exact time. So when you bring in another ball, let's bring in ball 7, and you'll see he has to start at a completely different place, so not to cross that center line. Okay, enough. Then I think what it is, I'll put this file out there and you can play with it. I'm going to turn them all on again. Okay, I'm going to speed it all the way up. Just hit the up key a bunch of times, and you can't even see it. I'll hit the down arrow a bunch of times. And that's in its slowest mode. A lot of that was for testing. Okay, a lot of stop points in there. That's probably the normal speed there. H for help text. Okay, so we did every one of them except for the debug. I'll hit the toggle switch for the debug. Okay, and you'll see here it will slow it down. It's calculating all these different various addresses, and converting them over to ASCII and printing them on the screen, so it keeps track of everyone, even if they're not even on the screen. You know, it would do all the calculations when it gets ready to print it. It will see if it's toggled on or off the ball itself. So you can speed it up, slow it down, in for no lines. And it looks like it's spinning around like the original one did. You can see if some of the balls are out of place, but I'm done. This took a lot of my brain cells and lots of hours. So I think that's it. Okay, I'll put the file out there. It will have the basic program, the table file, and this executable and the letters file. So there'll be four programs out there plus the PDF. You can read about it and play with it and say, okay, well, he did it, that's fine, and go on with something else. So that's it. Thanks for watching.